Hi everyone. So we are 1 minute until we start. Good morning, good afternoon, or good evening, I guess, for most of you guys. So we just wrapped up the Solana workshop, and now we're just jumping straight to another ecosystem. So that's the cool part of Wormhole, I guess. So now we're gonna have a workshop with Sui. There's three people today. They're going to come. So first is going to be Harrison. He will introduce himself very shortly. Then we will have Daniel, DevRel engineer, and Alex, who's also a DevRel engineer. We'll talk about Walrus, which is the new Mist Lab product. But I'm gonna leave the floor to the guys because I mean they will explain better than me. As usual, you know the drill. If you have any question, you can just write them into the chat. We'll try to answer them all. If there's many questions, we'll answer after each speaker. If you want to keep it all in the end, we'll just answer in the end, or we will always get back to you on it on Discord if we don't have enough time. All right, guys, you have the floor. I'm gonna withdraw myself.
All right, thank you, Pauline. Yeah. I'm also gonna just ask you to perhaps maybe hide Alex and Daniel as well, so that's just so that they can have a rest. Awesome.
Do you see your screen though?
I see my screen.
I will send the boys to the wing with me.
Right.
Can you, Alex? I need to send you as well.
Alrighty.
Here you go.
Well, thank you, Pauline, for getting us started.
Engineering, you know.
So this is a Telegram group that we created for the Wormhole Sigma Sprint Hackathon Suite Track. So if you are participating in this Suite Track, then by all means, please scan this QR code and join. Don't worry if you missed this right now, you'll also have another opportunity to scan this at the very end of this talk. So my name is Harrison. I'm a developer advocate at the Sui Foundation. I'm based in Seoul, and I organize in-person dev events or in-person and online events like this one, hackathons or workshops, hacker houses, mixers, and so forth. A little bit more about me. When I was a bit younger, when I had more hair, people would say, "Hey, you look like Glenn from The Walking Dead." But I started losing some hair, and I stopped hearing that comment. But only until recently, I heard this comment saying, "Hey, you look like the guy from Beef." So I'm just really happy Steven Yeun is losing hair. I hope he continues to do so that we're on the same page. All right, enough about me. Let's talk about the evolution of the internet. So I'm just going to give you the very high level of Sui so that anyone with both technical and non-technical background can understand Sui at a high level and then the direction that we're heading. And then later, Daniel will be speaking about Move, the features of Move on Sui. And last but not least, we have Alex, who will be going over Walrus, a storage protocol layer. So first, I want to ask who has heard of this? You guys can hear this. I won't play the whole thing. Hopefully we have enough people in this room who recognize this sound. It's basically the first version of the internet where we had dial-up internet where there's only one phone line in each household and only one computer has access to the internet at 56 kilobits per second. So let's just say a 10-second TikTok, Instagram, or YouTube video, how long would it take to load at that speed? 6 minutes, 6 seconds. And then that was the day before MSN Messenger or AOL. There was something like this called ICQ. Who's seen this? Who's old enough to know ICQ? All right. So back then, ICQ, you're just given a long string of number as your username. You don't have any choice on customizing your username. You're just given that. And that's kind of similar to the wallet addresses that we see today, right? You're just given a wallet address, a long string of number and text, and you just keep it safe or memorize it and share it with others. So UX was pretty bad during this time, this era. So ICQ emails, boring games like chess, and these were only like read-only websites by governments, owned by governments, universities, or large companies like Microsoft. Next came the ADSL era. Internet's a little bit faster at 1.5 megabits per second in the 2000s. And you have YouTube, but you have to pause halfway, let it load a bit or buffer a little bit, and then you can play again. You had Facebook, but without any of the videos or images, just text, right? And then later on, maybe some Instagram photos and MSN messengers. You can customize your own username. So a little bit better UX, a little bit more functionalities on the internet in general. So again, a 10-second video, how long would it take to load? 13 seconds. So a significant increase, but still a lot of us today with 13 seconds to load a 10-second video, we'd be pretty frustrated. Next came along the fiber optic cable speed or era, and maybe 20 to 60 megabits per second, something that we're used to today. So we have YouTube, Netflix, Instagram, or TikTok, and so forth. So today, it takes about half a second to load a 10-second video. So just imagine Web3's general internet speed today is still operating at the dial-up modem speed of the Web2 world. So we have not so great gaming experiences, just very static, boring games. And to fix that, to make Web3 more adoptable to today, is basically make that speed faster. And that's the goal of Suite, basically, right? How do we make Web3 faster and safer for everyone? So we try to achieve that with our chain, our Suite network chain, and our language called Move. So our goal is to onboard the next billion users in that manner. And first, let's go over how the network architecture is. So the traditional blockchains problem have slow processing speed and security risks. And I want to share with you two analogies today. The first one is a house. So let's say we have 4 rooms in a house, and only one person can enter the house one at a time. And each time one person enters, no one else can enter the house. So it's very sequential, one after another, pretty time consuming. But the Sui blockchain, we can have multiple people enter the house at the same time, concurrently or in parallel. And person A can go to room A, person B can go to room B, and so forth. Person B does not have to wait for person A to enter the house or enter room A before he can enter room B. I'll just skip over that for the interest of time. So this is the second analogy. Let's just imagine the immigration line where you only have one immigration officer, and everyone's lined up in front of that one booth, one lane. So how can we get this line getting through it quicker? Well, obviously, you can have a lot more lanes. Okay, so add more immigration officers. So that's a little bit better. But at the airports, we also see other types of lanes, right? Nationals, foreigners or visitors, diplomats, flight crew, families, right? So we have specialized passages. But let's just also imagine there's someone like Xavier X who already knows what your status is, right? Like, oh, you're a family, you're a flight crew. And it recognizes that you don't need to wait in the same lane. So it will create new lanes for you, new specialized lanes for you on the go. So, and that's kind of like how maybe person A's NFT transaction and person B's smart contracts transaction and person C's sending tokens to a friend. These transactions have nothing to do with each other. So they can all get their own lane and go through it instead of all lining up on the same lane and taking forever. So other chains, let's just say Bitcoin is one long line, and then Sui network, you can create infinite lines, basically. Now over to Move, the coding language. We treat everything as an object. So a token, NFT, a smart contract is an object. Basically, everything is an object within the Move ecosystem, in the Sui Move ecosystem, and in that way, we can provide better coding experience for Web3 developers, but also it's very useful for preventing security issues. So on Move, re-entrancy attack is impossible. And basically, the model is when Sam Blackshear, who created the Move coding language, who's the CTO at Miston Labs, the model is how do we help developers, or the question he was solving for is how do we help developers spend more time building the product and less time worrying about security. And that's basically, in Web2 world, regular engineers, they also don't have a background in security. So when they build a website, they also shouldn't have to worry about getting hacked all the time. They can just focus more on building. So object orientation is key for smart contract success. And so far, we've had 0 smart contract hacks. This is our URL website for the developer portal. And just very quick as well, Stack Overflow runs this developer survey once a year. I'm sure most of you in this chat probably have seen this before. And last year, there were 87,000 responses. And Rust is a quickly growing coding language where tech giants like Mozilla, Amazon, Dropbox, Yelp, Cloudflare, they're all moving to Rust because Rust is basically security first. Now, although Sui is not the same as Rust, but basically at compile stage, it does not let you compile unsafe code. So if you don't meet the basic safety requirements, then your code won't even compile and you'll never be able to deploy the code. So yeah, Rust is the most admired language, which is up here, and then Solidity is down there. Anyways. Also, another quick anecdote is we all know the popular JavaScript front-end frameworks, React, Angular, and Vue.js. And back maybe 10 years ago, there was Angular Vue that was ranked higher than React. And then now it's clear 10 years later, React is the clear leader in terms of front-end framework. So React was developed at Facebook. And what's another coding language that was developed at Facebook? For those who said Move, you guys get A+ in my books. So Move was developed during when Facebook was creating the Libra or DM project. So Sam Blackshear created the Move language, but since then, after working on Sui, Sam and his team worked on improving the Move to become object-oriented. So maybe in 10 years' time, Move will become the leading smart contract language for Web3, was the comparison I wanted to make with React. All right, so we want our developers to spend less time worrying about security and spend more time building on their products. And we do that. So again, we want to create a safer Web3 environment. And just like there was React, hopefully in the Web3 world, Move is up there for the smart contract language. So Sui is the next generation blockchain driving the internet revolution from Web 2 to Web 3. And I don't know if you guys have heard of this Mysticeti, but we recently had an upgrade for our network so that our latency is now drastically reduced. And basically, it's 3 times faster than before. So this is a trade that's happening on Jupiter. And you can see that it'll take about, not long, like maybe 4 seconds. Let's see, 3, 4. Okay. And then let's compare that with on Kriya Dex, which is one of the dexes on Sui ecosystem. And that's it. That was done in less than a second. Right. So we're focusing on frictionless experience now because we want to bring in the next billion users. And that means we should focus on Web2 users. But in the current world, we have this very complicated user experience, onboarding experience. So we have something called ZK Wallet, ZK Send, sorry, ZK Login, which is one of our primitives on Sui. And we allow people to log in with their, basically they can create a Sui wallet address using their, let's say, Google email or Twitch. And on the back end, it'll create a wallet, a non-custodial wallet. And Sui Wallet won't know what your Gmail address is, and Google won't know what your Sui Wallet address is. And we achieve that using cryptography. We have a lot of engineers from all over the world and top cryptographers working on technologies such as this. So there's this website called getstash.com, and if you go over there on your own time, and you can sign in with Google. And once you sign in with Google, you would have a Sui wallet address. Right now, you can see that this is my wallet address with 12 Sui. And I can click on it and enter 1 Sui that I want to send. And then next page, I can create a link or select an address. And I can send it to someone who has who understands what a wallet address is, right? And I can enter their wallet address that you guys are all familiar with. We also have something called, so on this website, Stashed, everyone can kind of create like a username or like a domain name. And then you can enter, let's say, Tesla as Stashed, and I can send that 1 Sui to Tesla as Stashed right away. But let's just say I can create a link right now for 1 Sui. It'll generate the link, and I can share this link through WhatsApp or Facebook Messenger to my mom or dad, and they can collect it. And they would also follow the same flow. Log in with Google, and they'll be able to claim it. Some of you are probably scanning this QR code right now. I already reclaimed it. So there's this reclaim stash button at the bottom, and it'll basically come back into my stashed wallet. I can click on the history as well, and when I'm hovering over this mouse, you can see on the bottom left corner, you'll see the block explorer URL. All right, so again, Sui is the next generation blockchain. It's on another league. The fastest transaction per second we reached was close to 300,000. We've had 0 attacks. So, and time to finality you saw was all under a second. And we've been partnering with great partners, especially in the gaming industry. But why gaming industry? Again, because we want to onboard the next billion users into Web3. And we have so many primitives that Daniel will go over later. But these primitives we feel are best exemplified in the gaming industry because there's the need for like randomness, composability, and all of these various factors that we find like gaming industry is the best industry to showcase all of these wonderful features that we've been building. So I'm just gonna again, like gaming, one of these games would bring on so many users, right? Hundreds of millions users. So that's why, again, it's win-win for everyone. And within gaming world, sometimes they would like to sell their items that they earned in the game. And in Korea, this already started happening like in the early 2000s. So I'm really excited for this day to come, when like truly fun games, not just boring games, but like legit fun games come online on Web3. I'll gloss over these because Daniel will go over these. Gas costs on Sui, so minting, I think this one is the stats for minting 1 million NFTs, I believe. Oh, sorry, 100,000 NFTs would cost 430 US on Sui. And then on Ethereum, more than 5 million. On Solana, approximately close to 100,000. And Polygon, 2.2 thousand. So how do we take gaming to the next level? Okay, so that's the SweetPlay OX1, and this will be launched in the beginning, in the first half of 2025 or H1 of 2025. It's basically Web 2 and Web 3 games in one handheld device. So you can kind of imagine it as like a Steam Deck, but for both Web 3 and Web 2 games. Here are 4 other partnership announcements that I'm really excited that I mentioned yesterday. You can find it on my Twitter account. I pinned it at the very top, and it includes 1 championship, 3 DOS, a 3D printing company, and USDC, we all know, but also DeLorean Labs. For those of you who need reminding what DeLorean is, I'll show you this quick video.
Who are you?
I'm just gonna skip to the end.
The future.
There's a capsule. All right, so I am thrilled about this. I hope you guys are too. Obviously, that's Doc from Back to the Future, and we're partnered with DeLorean Labs to bring DeLorean Labs onto Web3. The next round of, basically, go check it out. Go check out my Twitter. So I'm gonna skip these, and if you forgot my whole talk, basically the goal of Sui is to onboard 1 billion users, and we do that through the Sui network or the Sui blockchain and the Move coding language on Sui. And it's again to provide the faster Web3 internet speed in a safer environment. And we're trying to make it easy for everyone, end users, the developers, the vendors, the validators, and so forth. All right, so now I'm gonna invite my coworker, Daniel, on stage. If Pauline can help me do that and kick me off stage. Thank you.
You are kicked out. Daniel, all good?
Yep. Wait, can you
So
turn off the screen?
Daniel,
Okay.
you would need to share. Okay.
You can just
Okay,
reshare.
Okay, can you guys see my screen?
Yes, we can.
Okay, let's get right into it. So I'm gonna give like a very brief introduction about Move on Sui. So I'm Daniel, and I'm currently a developer engineer at Sui Foundation. So let's so this is my information. I'm a software engineer since 2017, Web3 since 2020, and I partake in most of activities for Sui in Vietnam ecosystem. So the first thing I want to highlight is that Sui is the fastest growing non-EVM chain. So here are all the achievements that we got currently. The all-time high 1.1 billion TVL, total 22 million active accounts and 1 million daily active accounts. All very impressive numbers. And you guys may wonder like why we grow so fast. What are the main reasons why we receive immense support from the community? There are various factors, right? In the crypto, especially in crypto, we got like market sentiment. Maybe like depends on different growth strategy, but I want to talk about like how we have like the technology advantage, and we believe that our technology will change the world. So I want to present like the main difference that makes us distinguishable from other blockchains. So transaction on Sui is blazingly fast. Up to date, Sui is the blockchain that handling the most transactions. 5.7 billion total transaction and 100 million daily transaction. So this is like a very impressive number that I don't think you can see in most blockchain in the market. And the fee instead is incredibly cheap. So for minting 1 million in NFTs, it's gonna cost you around like 6.6 like 6.6k USD. And on Ethereum, it's gonna cost you about like 33 million US dollars. Solana is gonna be around like 250k, and for Polygon, it's gonna be around like 30k, right? So Sui is incredibly cheap. And actually, if you decide to burn your NFT, you can actually receive a refund from Sui from a storage rebate. So there is like a small text here, but you can read it. It's like if you can receive like maybe up to $3,600. So I'm gonna move to the next slide. So, and yes, the reason why we can achieve all these like performance and cheap gas fees that we come up with a very unique architecture, and we actually have a name for it, and it's a Sui object-centric architecture. So today I mainly talk about it and talk about like how Sui and Move on Sui in general. So what is like the current problem with the traditional blockchain architecture, right? So if you look on the left side, it's going to be the traditional blockchain. So for the traditional storage, there is one single big state or resource, um, and for because like there is only one big resource on the state tree, so everything must so every transaction they must be processed sequentially, because like they need to process it in a way that they they have to uh, process in order so that they don't they don't cause any conflict to the state. But with three blockchains, we have like a noble storage. Instead of having like a single big state tree, we divide the storage into smaller piece of state. So for example, if the transaction touch the state A in other transaction touch the state B, we don't need to wait for two transactions to wait for each other. Instead, they can execute in parallel. So that's the main reason why Sui architecture is one of its kind in the industry. So everything on Sui is an object, right? Harrison mentioned that before. Everything on Sui is an object. Object is the first class citizen on Sui. Object, asset, and NFT, they all refer to the same thing on Sui. Object can be designed with a rich set of attributes with no limitation on your imagination. Object is a basic unit of storage on Sui. What I mean by the basic unit of storage on Sui. So if you look into the diagram on the right hand side, you will see that this is like this is a very minimal description of what like the storage looks like, but we have like an object ID, and for each object ID, it points to the object, right? It points to the object instead of having like an address kind of thing in the traditional blockchain, but instead we store object as the basic unit of storage. So for each object, it is gonna be object data and object ownership. So I will get through these things later through the next slide. So for NFT, Sui versus like traditional blockchains. So this is like the difference on how we actually bring NFT totally on chain. So for example, if on Sui, right, you have like an NFT called like a dog with a hat, for example. So with Sui we can actually store the skin color, the hair color, any attributes on chain. But with traditional blockchains, what you usually see is that you can only store the ID on chain, and all these off chain like skin color, hair color images, they need to be stored off chain. So basically, this is like the main difference. So NFT on Sui can be totally and fully on chain. Dynamic NFT is supported by default. What I mean by dynamic NFT is that you can actually change your NFT on chain, and you can have like a nested NFT inside your parent NFT as well. So this allows like the NFTs to interact with each other in the most creative way, allows like the NFT application to become richer, especially for gamings. Because like in a game, they design characters, they design items. Instead, like right now, the basic approach is that they do like all the interaction between the characters, items of chain, right? But with Sui, because like we can bring anything on chain, so that's allow like almost most of the action to happen on chain. And if you haven't checked out Studio Mirai, I think you guys should check it out. So Studio Mirai released their NFT collection a while ago, and this is, I think, the most technical NFT collection in the space. So with Sui, your digital assets are fully on chain. That's the highlight here. So please remember this one. So what I mean, like digital assets, right? Digital asset can be anything. It can be your pen, it can be your money, it can be your wallet, it can be your AirPod. But on traditional blockchain, so what usually we talk about coins, we talk about tokens. So on traditional blockchain, there is usually a smart contract approach is that they trap the user's assets. So if you look on the diagram on the right hand side, see that usually the smart contract is designed by a mapping between the account address and the balance, which means that um, your balance, your tokens is actually decided by the smart contract, right? The token is trapped inside it. So based on this observation, we can see that the user, they don't really own the assets. There is no direct management over the assets, and the risk of losing assets until they don't lose their account still happen. And you can actually see that there are a lot of hacks going on um, inside the traditional blockchain ecosystem. But with Sui, we are proud to say that we got zero hacks until now. So, but with so the next slide is gonna be like about digital asset on Sui. So with Sui, because like we store object is the basic unit of storage on Sui. So if what we store is that what we store is that if Alex owns like one token X, we're gonna store that okay, Alex owns one token, but is owning three tokens, for example, and that relationship is encoded into the Sui storage. So you can, so it's clearly defined what is the data and what is the relationship and ownership looks like inside the storage. So with this approach, we allow true ownership. Alex and Bob can actually own the assets. They can have the decision over the assets, and they must be responsible for their own assets. So if I have like the analogy to describe this situation, it would be for traditional blockchain. You can think the smart contract as a bank, right? Um, when you deposit your money into the bank, actually, like logically, that's your money, but physically, the bank own your money. So what you have is just a number, right? You don't own the physical money paper or anything. So that's the same thing for the smart contract on traditional blockchain. You actually don't own your money. The smart contract own it. It just logically they tell you that you own it. But with Sui, you actually own the money. Anything if you lose the money, it's your fault. So you must be responsible for your money. Next, I'm going to move to some of the Sui native features. So we currently have ZK locking. So because like we know that onboarding Web2 user onto Web3 is a very inevitable mission. We allow like Web2 user to use their social login like Google, Facebook, Twitter to create a wallet. And the best thing about ZK locking is that it's actually a non-custodial wallet, unlike other solutions in the market. We have kiosks, which is like a commerce tool on Sui. It's allow you to it basically like an NFT marketplace, and they enforce with some policy so that the user trade the NFT through the marketplace. They must abide to some rule enforced by the marketplace, and everything. And the best thing about kiosks that everything happen on chain. You don't need to rely on, for example, OpenSea or any external or third party vendor to to use the marketplace. Everything happen on chain and supported by Sui natively. Um, Another thing I want to talk about is like a deep book. So a deep book is the central limit of the book DEX on Sui. So usually the DEX that usually see is the automated market maker. But with book is the central limit order book like you usually see on CX like Binance, like Coinbase. Uh, but but the best thing about book is that it's the order book, but happen on Sui, happen on chain. So you can actually use the book um, like as the liquidity platform on Sui. Another feature is like sponsored transaction. So for some cases, like usually we build this feature because because like we want to onboard Web2 users, but usually they don't know what is the gas fee. So we allow like the application team or like the projects to sponsor the user transaction without like having the user to set up like to 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 figure out a way to deposit the gas fee into the wallet. Another feature that I don't think most blockchain have is that storage rebate. So the storage on Sui can be deleted, so the object can clear. So whenever the object is clear out of storage, we refund the storage fee to the users. So this is one of the most important features that I can actually say that is very impressive because if you think like you store a lot of object on Sui, right? But now you no longer need it, and you can actually get the money back. The last features I want to talk about is program, programmable transaction block (BTP). So basically, we this is a very unique feature as well because like we allow the client to compose transaction blocks. So for example, like if you have like smart contract A to offer like a function A, another smart contract B to offer a function B. So right now, if you want to change those two functions together in a transaction, what you usually do on the chain is that you need to create like a new smart contract with a function C to call like a function A and B. But with Sui, we allow the users to do that from the client side. So you don't have to create like a new smart contract to call to change several transactions together. That's totally can happen on the client side. Um, so the next part would be move on Sui, I would say. So let's get right to it. So Sui is like you can think of Sui as like a CPU or RAM. That's the whole architecture. But the way you interact with Sui is using a move smart contract language. So move is designed to center around assets. It empowers security. And because like it designed to center around asset, it actually fits the Sui object-centric architecture. So the first feature is that move empower dApps with proper vocabulary. It's very expressive, meaning that whenever you look into the function or you look into the move code, you can read and you can comprehend what the code is actually doing with your data. For example, for this function, it's a buy a coffee, right? So when you look into the function, you can see that you need to give a payment with the coin of Sui. You need to go through the cash register uh, in the context of a transaction, and after that, it kind of gives you a coffee back. So basically, when you look into a function, you can predict or like comprehend what will happen with your data. So it's very expressive. Uh, Another feature would be semantics. So Move has a semantics for reference, which is like not denoted with the ampersand character, and a mutation meaning the reference with the mute keyword and the ownership. So if you look into this function here, it's called like a claim coffee. So they need a card with a membership card. Uh, so you can only get a coffee by proving if you have a membership card, right? Because in Sui, you can only input an object into the function. You can only call a function with that like input data if you actually own the data. So if you if you don't own any membership card, you cannot call this function. So that is the guarantee that Sui has at the VM level. So you don't. So that's the reason why we probably say that we have no zero hacks, because only you can transfer your money. Only you can transfer whichever objects that you own. You must like you have like total responsibility over your objects. Um, Another like example is that you need to buy coffee, proving that you have a membership card and update the membership points. So basically, if you look into the function, it's very expressive, and you can understand what's going to do with your data. Okay, um, so to there is like a custom user defined type. So in modular functionality, you can declare like your data type in different modules and have like custom data inside of different modules. So for example, here like we have like a module called membership, right? So you can declare your own struct and data type here with like the function that what we can do with that data type, and you can declare another module. So basically like it's basically like what you usually, if you guys are like the Web2 developers, you can see that like the paradigm and the coding flow is very very similar to what you code with your Web2 projects. You have like different modules to encapsulate different responsibility of your function, and then you can interact like and then like one module can interact with another. So let's move to the code. The code organization is smart contracts. Um, so like in so a project, a Swiss smart contract project is that there is like a module, is some minimal unit of code abstraction. Packages can have one or more modules. Packages are immutable, meaning that if you deploy it on chain, with like you deploy the code on change, it cannot be modified. So we can, but we allow like the developers or projects team to publish the upgrades for a package. So if you decide, if you want like to modify some logic in your functions in the package, you can upgrade your package. But because like packages are immutable, so whenever you upgrade your package, it's actually create a new package. Uh, so the smart contract in Sui is actually a package. So a package, they have multiple modules. So that is the main thing that you need to remember from this slide. So move data types and abilities. So in move we support like the data types that you guys usually see in different languages. Like primitive types we support inside integers, inside 8, inside 64, inside and up to like inside 128. We support boolean type, we support address type, and for built-in collection types we have vector and user defined struct. So basically, what you can imagine with some other languages that you already work with before, you can actually imagine that you have like a very similar data types in Sui with move abilities, right? So move ability is something we custom the behavior of the struct. So if you look into the code here, I will explain it in this slide. So if a struct has a key type, so there is like a keyword with a key with a key ability. This means that the struct A can be stored in a global storage. So if a struct doesn't have like the key ability, which means that it cannot be stored in the Sui global storage, and it's just a struct, it is not an object. This is not an asset in Sui. So a B, so for a B has like a store ability. That means that the struct B can be nested inside another struct. So with move, so we move to the copy ability. So with move, C is because like move is designed to center around assets. We don't an asset cannot be like copy or like deleted. They cannot like copy or delete it automatically, but instead you need to create it yourself, and you must like destroy it yourself manually, meaning that like so that's the reason why we have like a copy ability, meaning that that struct can be copied. So the default behavior of a struct is that it cannot be copied. Instead, it's going to be moved, and it's going to be moved or take over like the ownership. And the same situation happens for samining, happens for drop ability, which means that you have to like delete it yourself. And if you have like a drop ability, means that this drop can be dropped automatically without destroy manually. Okay, so there is like I would say let's make this a quiz. So we have like a hot potato, which is a very special struct with no abilities. So I want to have you guys take a look at this, and this is a very important design pattern that I want you guys to take a look at this and maybe leverage that to use in your applications. All right, so in Sui, we talk about a lot like objects and ownerships and composability on Sui. So let's move to that. So everything on Sui is asset, right? Like I already told you. So to make an asset or like an object, we have to decorate a struct with a key ability, right? We already learned that in the previous slide. So a smart contract itself is actually an object, but it's immutable. The smart contract manipulates objects on the Sui network. So there are like many different types of ownership on Sui. The first is the address on objects, meaning that for example, like I own the pen, right? So that object is owned by me. So in on Sui, I am represented by an address. So basically, address is just like a wallet, and it's actually a 32-byte address. So so this is like the whole like the first type of ownership in Sui is that you have like address on the objects. And you can use this function to actually transfer the ownership of the objects to different wallet, to different address, or to different person. The second type is like the share objects. So share object is meant to use and share by everyone. So basically, like I say, like if an object is owned by me, right? So only I can use that object, which means that for every function that I call on a smart contract, I must own the data to call to use that data inside the function. So a share object is it is shared by everyone, so everyone can use it inside the function of a smart contract. Because like the share object it doesn't have like a real owners, so so to make like an object and share object, you can use a share object function here. Another type of object is immutable and frozen. So basically, immutable or frozen objects are share object, but they are not allowed to be like mutated, transferred, or deleted. And you can use the function called transfer public freeze object to freeze the object. So what happens with freeze object is that because they cannot be deleted, they cannot be modified, so we can use it to bypass like the consensus mechanism to use the objects like through the fast path so that they don't have to wait the consensus. Okay, so wrap object on Sui. So to build like a richer application, we allow objects to be nested inside the objects. And that's what we call wrap objects on Sui. So we have like direct wrapping, meaning that we put another object inside another object. So that wrapped object must have a starability. And a wrap object cannot be enwrapped unless the wrapping object is destroyed, which means that if like an object is already wrapped inside for example like an object B, right? They wrapped inside object A. So the only way you can get the object B back is to unwrap the object A and pack it so we can access object B. So whenever like an object is wrapped, it becomes part of the wrapping object and it is no longer accessible independently by its ID. So you can no longer look up the wrap object on chain. The only way to look at it is through the parent object.
Daniel, you have 2 minutes left.
Okay. I think it's almost over, so I'm gonna move quickly. So another like wrapping style is that you can use with dynamic fields, which is a very unique features and unique native features on Sui. So if we back into like a wrap object on Sui, so you need to declare a field beforehand, right? But with dynamic fields, you don't need to do that. You can actually dynamically add the fields based on according to some logic on chain, right? So for example, if you have a game which is like a character, right? But right now the character is new, and that character doesn't own like a wallet or like a sword or like a shoes yet, right? But along a game, he will earn those objects, and we don't know beforehand that he will need a sword or like a shoes or like a pen or whatever, but we will know for sure that he's gonna earn something. So with Sui, we allow you to dynamically add the objects without declaring it beforehand. There is like a Sui type, data type, that very special type is called table and bag collections. It's actually implemented with dynamic fields. So this is a very powerful features that you guys should use in your hackathon. Okay, so access control, I think I already gave a quick like overview on this. So because like I say, the only way that you can access to access the data is that you must own the data, or it must be shared across like the whole Sui ecosystem, right? So the only way that you can call this claim coffee is that you actually own a membership card. So this leads to like a design pattern where we allow like access control remove. So for example, if you have some function that requires like the administration to actually create a coffee, for example, then that person that called a function must own the administration capability to actually call a function. So this is like a design pattern that I think you guys should take a look and actually use that in your next Sui applications. Okay, so I think I finished my part, so I'm gonna give it to Alex for the Walrus thing.
I would move Alex to the main stage. Of course, I do have an issue on my screen for whatever reason. Okay, it's a bit of a bug on the on my screen, so I don't know how to put you back on stage. Alex, maybe you can talk without having. Can you talk?
Yeah, if you can hear me and if you can see the screen, then it's all good.
Yeah. Sorry, it's a bug. It's a bit buggy, and I cannot put
Yeah,
you back
it's
in.
okay. It's okay. So hello everybody. I'm Alex, and I will very briefly go on the next innovation from Misten Labs. Misten Labs being the company that first started Sui, but it's still an infrastructure company. Sui is now under Sui Foundation purview, and they are moving on with new innovations. This one is called Walrus, and yeah, this is me. I will skip over many of the slides in interest of time. The agenda is like what is Walrus, some key concepts, and how it works with Sui. So Walrus is just a decentralized storage platform. It's provable, available, and secure means you can prove the existence of the data. There's always availability is guaranteed, and secure in the sense that it cannot be altered. The issue with storing large data on chains, it's something that you probably very well known that chains have validators behind them which keep the whole state in memory. So if you want to share a piece of data, then all the nodes have to get it, and this is an issue that trips up, and it takes a lot of time, and it's not really efficient. For this purpose, Misten Labs has come up with Walrus. It's again a decentralized platform. Again, it has nodes, but they have an algorithm for the replication factor that it doesn't need to go through every node. It's much more efficient, and it's designed mainly for storage. So the storage cost is very cheap. Of course, it's not an actual blockchain, so you cannot do logic on the storage. Its purpose is mainly and only storage. So let's see some key concepts. There are several storage nodes. These will be the validators of the Walrus. There is a publisher, a client software that allows you to store stuff on Walrus, and an aggregator that allows you to read stuff and retrieve, and then you can even use caches over them. The way it's done on a very high level, the basic unit it's a blob, and on the background that it's sharded into slivers, and then actually it's divided into slivers, and then the slivers into shards, and each shard it goes to a storage node or to several to a storage node, and then you can retrieve the data by getting all the shards, getting all the slivers, and then getting the blob. It is BFT resistance, of course, and as long as one third of the symbols are available, then you can recreate the blob. This is the flow diagram over here. So if you have a client like a CLI, you can talk directly to Walrus, or you can use Sui to talk to Walrus. Otherwise, you can go through a browser and use existing software there that are called either publisher or aggregator in order to read and publish your data. Walrus is not a Sui feature, but Sui can become a control panel for Walrus if needed. But Walrus is also compatible with any other L1 out there. So yeah, Walrus is compatible with all L1s, but because it's made by Misten Labs, there are a few more features on Sui where you can directly create a blob on Sui, and you can then store it on Walrus, and also get proof of availability, or even manage it through the Sui blockchain. This allows you to create a totally decentralized application without needing any Web2 centralized servers. So the operations of Walrus, of course, are just store, write, read, retrieval, and certify, or otherwise, in other words, prove that the data is there. So certify means that you can check that an object is there already. Oh, sorry, I'm going too fast. Store, yeah, you can store a blob, you can store a piece of data. A blob might be up to 957 right now megabytes, but that will increase. I have to mention that Walrus is still on DevNet, and soon we will have testnet, but mainnet will be a bit far off in 2025. Then you can read the data that it's stored, either through SWI, either through the other way with a client or an aggregator. And certify means that you can get a certification or an okay that the data is actually there. Walrus site, so the documentation that you can find that this QR code is actually stored. You will be transferred to a site, but that site is stored on Walrus already. It's kind of funny anecdote, and you can also have store full websites on Walrus if that fits in your use case. And yeah, I went a bit fast. Please check the documentation for us if you're interested, and if your use case needs a storage layer that is cheap and fast. Here is the TG group for the Wormhole Sigma sprint, and we will be available to answer all your questions regarding anything SWI or Walrus during the duration of the hackathon. Thank you very much.
Awesome. Thank you, Alex. The background noise has stopped the second you stopped talking. So for some reason, but that's all good. Thank you so much. Can you stop sharing? Because I cannot move that thing. I cannot go back in the main stage. Maybe if you stop sharing. I think it's Alex that is sharing.
Yeah.
No. then Daniel is alone. Okay. And I think I can, guys. I can do that. Thank you so much, everyone. Thank you for staying with us. We went a little bit over time, but I hope you really liked it. Yeah, check out Walrus. Also, we will put all those. Yes, you go.
I have a request.
Yes.
Daniel, turn on your camera. So whenever I host events, I like to do a little cult sign for our SWI logo. So
okay.
4 of us can do it right now, and then
okay. Let's do that. But who's gonna take the picture?
And then all you guys go SWI. All right. So here we go.
Okay.
1, 2, SWI.
Daniel, you. Yes. Good.
Daniel, you're muted.
Yeah.
Okay,
Are you
let's do
muted?
that again. I thought it was just like practice.
Okay, one last time. Here we go. 1,
but
2,
you want me to take
3.
a screenshot of this? I can do both.
All right, cool. We can take a screenshot afterwards.
Okay. All right. So yeah, thank you very much, guys. It was a very entertaining workshop. We'll put everything and all the link on the Discord as well. Please, anyone who wants to build with SWI, there is the TG group, which is definitely better support than asking me, because I suck a little bit at SWI move. I have to admit I'm not that great. That's why I ask Alex all the time. Yeah, that's it pretty much. Thank you very much, and see you around. See you for the next workshop, guys. Bye.
Thank you very much. Bye.